This is EGR 103, the design process for military engineering, Part 1, Design Inputs. Hi everyone, this is a set of 2 lectures concerning the design process for military engineers. This first part is going to be Part 1, Design Inputs. And let's see how this compares to our current design process. Here you can see the design process that we utilize. If you think of the proof of concept documents, they follow this. The only part that's missing in the proof of concept is perhaps the presentation part, which we're going to cover at the end of the semester. Now here's the military design process. This process is similar in shape. They call this a spiral model. The basic idea is that you're starting with the top box, established mission requirement, and then you're going down through to integrate, validate, effectiveness, and then from there you're going into the next project. So you can think of it as sort of spiraling. This comes from an older military standard called 499A, which was in effect from about 1969 to about 1999. Since that time, the military moved to using commercial standards. The big ones are from the Institute of Electrical and Electronic Engineers and the International Standards Organizations. We're going to go through all of the steps of this process. The ones that we're going to cover right now are in red. They're called the design inputs because they basically provide the input information needed for the designers and builders to produce an actual product. That actual product will be the design output. So the first step is the established mission requirements. This is similar to our recognize the problem. Generally, this is done by senior leaders in the military, but it's also done by the U.S. Congress. They determine the high-level needs of a particular military design. So in this case, we look at the SR-71 Blackbird. Its high-level needs, and high-level is really true, was to fly above 85,000 feet and faster than Mach 3. That's the kind of general guidance that's given to the military designers. And then they have to turn that into actual functional requirements that people can design from. So in this step, which is similar to our research step, we try to figure out the top level functions that this design will do. So in this case, we have these 2 cruisers here. So the function of the cruiser is to scout and do reconnaissance, escort aircraft carriers, and to support the U.S. Marine Corps. Those are sort of the top level functions. In doing this work, we often look at existing designs, and then we base our new designs on the existing designs. So you can see amongst these 2 cruisers, which were designed perhaps about 10 years apart, that there's quite a similarity to them. It's obvious to me that the designers of one were looking at the older design when they designed the newer ship. The next is to establish requirements, specifications, and constraints. Very similar to our define the problem step. This is where we produce the specific language that a designer can use to actually design something. So in this case, we've taken the USS Iowa class battleships, and that's actually the USS New Jersey there. And here are some of the typical requirements we might see. It has to have a 9-gun main armament. The guns are the 16-inch diameter, 50 caliber type. The guns are rifled, so they're a rifle. They're arranged in 3 turrets, and each turret has 3 guns. Now I have something specific I can use to design from. From here we develop concepts. Most all military projects have several concepts that the designers work through, and then they present those to the military. The B-52 is a really good example. There were multiple concepts done. You can see in this picture here, 2 up above is the XB-52, down below is the YB-52. They look somewhat similar. Probably the biggest difference that you can see immediately is that the XB-52 is a deeper aircraft. Deeper and maybe a little bit narrower. The YB-52 is not quite as deep, but is a little wider and perhaps a little bit longer. So from these concepts, then we evaluate alternatives, very similar to what we do in our evaluate your design sub-step. Multiple military and civilian leaders are involved in this step. Now what's interesting is that we may build models or prototypes. In the B-52, the Boeing company actually built several scale models of what they were proposing so that the military leaders could really get an idea of the look and feel. My experience is that in general, all of these concepts, and I'll go back a slide, all of these concepts meet the requirements. The difference is, do they meet the needs of the top military leaders in terms of mission, and do they meet the needs perhaps of the congressional leaders who may have a desire for a particular type of aircraft, or perhaps maybe even something that could be done within their district. The output decision is then the detailed design that we go ahead and work from. So we're going to talk about that in the next slide deck here. So stay tuned for part 2 of this, where we get into the detail of designing. See you later.